this much will be our slump value. So we can have nominal maximum size of aggregate. Then this much will be our ultimate target is compressive strength or flexural strength. These are our output. Primary output for the concrete design, there is actually compressive strength based on what we normally design our concrete mix. Nowadays, ACI in the latest development, it is trying to design the mix based on the modulus of elasticity. Previously, the method that is based on compressive strength. However, now they are shifting it to the modulus of elasticity. Gentlemen or beta students, the report or the ACI document which we are going to follow to design, that is ACI 211.4R. Make sure you have this document, you can download it, and it is also provided in the slides as well. So this document is regarding the complete guideline for the mix design. However, it's 1R is for the normal strength concrete mix design. So first of all, you start with the approximation. And very first trial you start with that, you will get an approximate mixture values. Then you make the trials. You go for any mix design. Then you would go for the trials based on the local characteristics of the material, and then you get the final mixture. Then what are the steps you follow? What are the major steps you follow in the mix design? You need to understand that the first part is you measure the job parameters, in which you have aggregate properties, maximum size of aggregate, your slump must be defined, water to cement ratio must be approximately is there. Either you are going to use a mixture or no. So this must be defined right at the start. Once you are going to prepare the mixture, then you do the calculation of the batch weight, and then you do the trial batches. After the trial, you adjust them. So this is the three-step procedure if you go for the mix design. In ACI mix design, water to cement ratio theory is very important. There, how much water you are going to add into the concrete. This water will be responsible for the strength characteristics of the concrete. If you add more water, although this will complement to the workability, but for sure it will compromise the strength. As long as your workability is consistent and your water is consistent, your strength, you can find out that at a particular water to cement ratio, you can get a specific strength. But as per the, you can say, literature, as you lower the water to cement ratio, your concrete strength is higher. So it means whenever you have a higher water to cement ratio, you are going to have compromised compressive strength. So it means that your strength is dependent on water to cement ratio. But at the same time, your economy is also based on that. So your concrete design is primarily dependent on that how much aggregate is available, how it is workable or not, and how much water you are adding into the concrete. So being a designer of the concrete, being a designer of concrete mixture, what you need to do, you need to get the optimum strength with minimum cement content and with the acceptable workability. These are the two primary objectives of a concrete designer. That whoever is designing a mix, he must be having that he will get that optimum strength with minimum cement content, and your workability should be acceptable. These are, you can say, the primary. So if you see that within this graph, that as you are increasing the water to cement ratio, your compressive strength is decreasing. This is, you can say, a well-defined, you can say, based on the literature, you can see that as long as you are increasing the water to cement, you never go beyond 0.7 or 0.8. After point 0.7, there is segregation. Below point 0.3, it is very difficult to mix. So this graph should be very clear to you that how your compressive strength is going to be, you can say, addressed. Are we clear, students, until now? If you have any question, you can ask. But if you have any question, you can ask. Otherwise, I'll move forward. Students, are you listening me?
Yes, sir, it's clear.
Okay. Now we'll move to the next slide. So one comes there, you need to have either air entrainment or not. Either you are going to make the concrete air entrained or not. This is very important, that your concrete is air entrained or not. So what is air entrainment? We add the air intentionally into the concrete so that later on, if we have microscopic air cells into the concrete, later on, if we have some expansion into the concrete due to the internal pressure, this expansion can be taken care of by these micropores. How this expansion can come into the concrete? Can anybody tell that? When there will be an extra internal expansion onto the concrete. Can anybody tell that why this air entrainment is there and how this internal pressure can be there on the concrete? These are the two questions. One question, let's say, keep it simple. When this internal expansion can be there into the concrete, कब हो सकती है ये, कोई बता सकता है?
सर वार्षिक होगा तो वो एक्सपेंड करेगा तो वॉल्यूम बढ़ेगा.
जी बेटा, कब कब पॉसिबल है कि ये एक्सपेंशन आए?
सर जब फ्रीज होगा वाटर कोल्ड टेम्परेचर में.
When we are in cold temperature, then there is a freezing. So that freezing can cause the expansion. So once we have these pores, these microscopic air cells, they can accommodate this particular expansive stress. So that's why in the cold regions, normally in the regions where temperature is in minus or negative, we do the air entrainment into the concrete. Okay, once our water to cement ratio is established and the workability is considered, what we need to do, we normally go for the trials, and after the trials we can get the required water to cement ratio. Now, as a concrete designer, as a concrete mix designer, our primary objective is to find out or get the maximum economy. So being an engineer, what is our primary objective there? We can lower the cost of material and we can lower the cost of labor and equipment as well. But this all is possible with the, if you see, the material is primarily dependent on the mix design. But labor and equipment, they can somehow engage, but some special cost type of concrete, just like if you say about self-consolidating or self-leveling concrete, there the labor cost is exceptionally lower. But in normal concrete, they are independent of the mix design. So we can control the relative costs. So it means if we can lower the cost of cement or content of cement, so we can lower the cost of mix actually, or we can lower the cost of concrete as the whole actually. So how to do it actually? This can be done basically by designing an optimum mix design. And this optimum mix design means we are using minimum aggregate with possible minimum cement content. These two things must be in our mind. So how we can accomplish this? There we are going to use the proper guidelines submitted or given to us by ACI 211.4R. Then second requirement, this is very important by the, you can say, client or by the workers, that is workability. If you are designing a mix and it is not workable, you cannot place it, you cannot compact it, you don't have a bleeding, you don't have a segregation, that possible mixture is required in the field. So, gentlemen, our second, you can say, highlighting or red blinking point while designing a mix is workability. Never ever we can design a mix without considering the workability. So if we design a mix and we don't give the, although this ACI 211 give a very strong cushion to the workability. So our water requirement is basically based on the aggregates and cement characteristics and also our workability demand as well. What site is asking to us? In most of the cases, site never asks, but in some of the important sites, workability is very important. So at least minimum workability should be there. Code says that at least your slump value as per ACI ASTM C143, or we say that your ASTM C143, that is test regarding the slump, your slump value should be 2 inch to 4 inch. So minimum 2 inch should be there. Slump value where that is our inverted cone test actually. So our mix should be workable. Then at the last we places, but it is the primary one. There is the strength and durability. Minimum compressive strength which we require through a mix design must be achieved. What we say there, whatever the design, whatever the mix design, whatever the standard practice, whatever is the code, we are given the value, let's say 25 megapascal. Once we do the mix after 28 days, our strength parameter should be achieved. Then secondly, we also take care of that our requirements for freeze thaw, chemical attack, or alkali aggregate reactions. These are or alkali silica reactions. These all are well taken care of. So if we take care about these particular parameters and then we take care the strength as well. Remember, in important projects just like dams or barrages, once we are doing the mix design, these all tests are very important. Before going to utilize any concrete aggregate, we do these durability tests and then we allow the aggregates. Then workability is measured by the slump test, as I told you. And slump is being measured by ASTM C143. This is a cone of 300 millimeter, then which is lift, and how much is the concrete leave, and what is the drop in height, that is our slump. So this slump value will tell us either our concrete is workable or not. This is mixed design procedure flow chart that we take the value of slump, then water and air content, then water to cement ratio, we find out the cement, then we find out the coarse aggregate content, at the last we find out the fine aggregate content. Second last step, we go for the moisture adjustment if it is a necessary or not, and then we do the trial mixes. These all are our step-by-step procedure to do the mix design. Now, mix design procedure. If you have any question regarding the theory, students, you can ask. Then we will go step-by-step procedure for mix design. No question, Ji? Students, are you there? Students, are you there?
Yes, sir.
बेटा आगे से बोल दिया करो, मुझे पता चले कि मैं किसी को पढ़ा रहा हूँ.
जी बेटर सर.
थैंक यू. अच्छा जी, अब हम चलते हैं इसके मिक्स डिजाइन के प्रोसीजर की तरफ. So number one, we require the material information. We must have sieve analysis of the coarse and fine aggregate. So for the fine aggregate, we need the fineness modulus. So if fineness modulus is known, we can decide a lot of things. We'll see in the upcoming slides that how we decide the water cement ratio and we decide the fiber aggregate content. So fineness modulus is important. Then unit weight is specific gravity, water absorption capacity. So this all information is required initially. Then the choice of slump. We need to decide that for this particular slump, we are going to design the mix. And there is a table given to us actually, that we choose the slump value either it is through 2-inch, 3-inch, or 4-inch. Just like over here, we select the slump and concrete strength. So this is our step one. In step one, we decide the concrete strength and we decide the slump. So either our strength is 9,000 psi, greater than 9,000 psi, or lesser than 9,000 psi. And that is given in, and the slump value is given in table 6.1 of your ACI to 11.4R. So if our slump before adding, we use 1 to 2 inch and concrete made without high range water reducing mixture. So two kinds of slumps we have. We can have values. We can go with it. So these slump values we can choose right at the start. After choosing the slump and now deciding the strength, we can select the maximum size of aggregate. What will be our maximum size? For this, we have a table 6.2, which gives us the size of aggregate. If our strength, decided strength is lesser than 9,000 psi, the aggregate size can be in between 3/4 to 1 inch. But if it is greater than 9,000 psi, we must have our aggregate size between 3/8 to 1/2 inch. Remember, this is very important. Most of the high strength aggregates, they are prepared with 1/2 inch down size. Clear? So whatever ACI 318 states that the maximum size of an aggregate should not exceed 1/5 times of narrowest dimension of the sides of the form, 1/3 times of depth of your slabs, or 3/4 inch of minimum clear spacing of the individual. So your aggregate should, maximum aggregate size should not be greater than this. इन 3 क्राइटेरिया से ज्यादा आपका एग्रीगेट साइज नहीं होना चाहिए. उसके अलावा ये 2 रिक्वायरमेंट हैं जो स्ट्रेंथ पे डिपेंड करती है. Then comes out that you will select the optimum aggregate content. So your optimum aggregate content will be decided based on the nominal maximum size of aggregate and your fineness modulus. If the fineness modulus of your sieve is in between 2.5 to 3.2 and your nominal maximum size of aggregate is 3/8 inch, 1/2 inch, or 3/4 inch, you can decide the volume fraction of your mass of your aggregate. So your volume fraction of your oven dried rodded coarse aggregate. Let's say your aggregate is 3/8 inch. So your volume fraction is 0.67, 0.65 actually. So 0.65 into bulk density into 27. So this 27 is actually, you are making it for 1 cubic meter actually, 3/3/3 cubic feet. So this is how you will find out the mass of the coarse aggregate. So to decide the mass of the coarse aggregate, you need 2 things. One is your fineness modulus, and number 2 is the nominal maximum size of aggregate. Any question beta until now? कोई सवाल बेटा जी पूछना चाहते हैं आप लोग?
No, sir.
नो, चलो आगे चलते. Next is, so once you have decided your volume fraction of aggregate content, now you will estimate the mixing water and air content. So your mixing water and content will be decided based on the slump value you have decided, and it is based on the maximum size of coarse aggregate. So let's say if your maximum size of coarse aggregate is 3 by 8 inch and your slump is 1 to 2 inch, your water content is 310 pounds per cubic yard. This is your mixing water content. And first estimate of mixing water content actually and air content using fine aggregate with 35% white content. It is saying that it is with 35% white content. If your 35% water is greater than 135% content, then you need to apply the water adjustment. So this is what it states that. Next is your water to cement ratio. So if you have the target required compressive strength, it is 9,000 psi at 28 days. And then your aggregate size is half inch down. So based on half inch down and 9,000 psi, so you can see your, with the high range water reducing admixture, your water to cement ratio is 0.36. So this 0.36 you got from the same table 6.2, 0.3, Your table 6.5 actually gives you the value of this water to cement ratio. Now, water to cement ratio is there with you. Water content is there with you. You can find out cement content or not. आप सीमेंट कंटेंट फाइंड कर सकते हैं अगर आपको वाटर सीमेंट रेशियो भी पता है और वाटर कंटेंट भी पता है.
Yes, sir.
So just you, it is very easy for you to buy water to cement ratio. You can find out the water content. This is step 6. Now you have the cement content with you. You have the aggregate content with you. You are designing for 27 cubic feet volume of one mix design. So you find out the total volume and you find out the rest of the volume for the concrete. Proportion the mix by, you can say, the mass of cement required as per the cubic yard, you can find out. Fine aggregates, you can find out the fine aggregate, you can determine by subtracting the other two proportions, cement content proportion, volume, then volume of aggregate, then volume of water. From 27 cubic feet, you can find out the volume of fine aggregate. Or even you can use the density as well. The total, let's say, density of the concrete is 2,400 kilogram per cubic meter. So you have found out the density of the coarse aggregate, you have found out the density of cement, bulk density, you have found out the water density as well. So you can find out the unit weight required for the fine aggregate. And after that, you can find out the mixing proportions of fly ash as a replacement of cement content. Once you have got the mix proportions, you will repeat the 1 to 8 step for the trial mixes. So after trial mixes, you will adjust the water to cement ratio and also you will adjust the admixture as well. After mixing admixture, addition of admixture, you will finalize the mixture. So this is our first example we will solve. Gentlemen, students, if you have any question, beta, you can ask. Then we will start with the example. जी नहीं है सवाल कोई?
No, sir.
Okay, thank you. Now we are asked to design a mixed high strength concrete required for the column in the first 3 floors of high-rise office building. The required specified strength is 9,000 psi at 28 days. So the largest nominal maximum size of aggregate is ½ inch. It is also given to us. Then the properties of the fine aggregate are also given to us. So high range water reducing admixture and a set retarded admixture will be used. So they have given us the values. So as our mix is 9,000 psi, our target strength will be 1.1 times into 9,000 plus 700. This is the formula for strength once it's greater than 9,000 psi or high strength mix is there. So we will use our target strength as 10,600 psi. So we will select the slump, and with the slump we have selected, that is 1 to 2 inch with high range water reducing admixtures. Because it is mentioned in the question that you will use a high range water reducing admixture. So our slump is 1 to 2 inch, aggregate size is ½ inch, and our target strength value is 10,600 psi. So then we will select the maximum size of aggregate based on the guideline 6.2. Our strength is greater than 9,000 psi. So our mix will have maximum size of ½ inch, 3/8 to ½ inch. So this is the step 2 is also very clear with us, as our strength is greater than 9,000 psi. So our aggregate size will be ½ inch. Now selecting the volume fraction by table 6.3. So if we go to the table 6.3 in step 3, this is our table 6.3. Our aggregate size is ½ inch and our fineness modulus is between 2.5 to 3.2 inch. 2.5 to 3.2. So our volume fraction will be 0.68 by this table. So if we see in the question, so our volume fraction is 0.68 by table 6.3, and it is being multiplied by with the bulk density that is being provided to us as 101 point something of fine aggregate, of coarse aggregate particularly, and then multiplied by 27. That is the cubic volume. We find out the total pounds weight in pounds dry weight of coarse aggregate. So this is our weight of coarse aggregate we have calculated. In mixed design, we have coarse aggregate, we have fine aggregate, we have cement, we have water. So we need to find out how many things. कितनी चीजें हमें find करनी है बेटा? How many things we need to calculate for the mixed design?
Sir, coarse aggregate, fine aggregate.
Coarse aggregate, fine aggregate, cement, and water. These 4 weights we needed. So in the step 1, we have calculated the weight of coarse aggregate. Okay. Is it okay or not?
Okay, sir. Okay.
Now we go to the second step where we will find out the water content. So for the water content, we will use table 6.4. The aggregate size is ½ inch down and slump value is 1 to 2. So mixing water will be 295 pounds per cubic yard. This is what we have calculated actually. So this is our mixing water content. That is what we calculated actually. Are we clear, Ji? This is our mixing water content.
Yes, sir.
Okay. So our mixing water content is 295. And this value is given for the wide content of fine aggregate as 35%. If our wide content is greater than 35%, we need to apply the adjustment, mixing water adjustment. So how we will find out that is this require any adjustment or not? We will find out that how much volume is there, how much percentage wide content is there. So we'll see that this is bulk density of the fine aggregate divided by its unit weight, specific weight. This is bulk density of the fine aggregate divided by the specific weight into 100. We'll find out that it is 35.03%. So it is not exactly 35. It is greater than 35 by 0.03. So what we will do, we will multiply it with air and we'll find out that this 0.24 pounds per cubic yard additional water will be added into the concrete for wide content actually, if as it is greater than the 35%. If this value is lesser than 35%, no need to apply any kind of adjustment. But primarily we will find out from here the water content. This water content is 295. So we found out the water content. Now we will find out the water to cement ratio. Our concrete target strength is 10,600 psi. So at 28 days, water to cement ratio we need to find out, because this is 10,000 psi, this is 11,000 psi. And our half-inch aggregate size, this is 3.32 and this is 0.29. So if we interpolate in between them, our water to cement ratio comes out to be 0.3. So our water to cement ratio is 0.3. If it is not exactly given to you, you need to find out, you need to interpolate. Are we clear?
Yes, sir.
अगर ये आपको इस टेबल में ना मिले बेटा, तो आपने उसके लिए यहाँ से exactly find out करना है. Now we have found out the water to cement ratio. Water content is there with us. 295 was water content. We know the water to cement ratio. We divide it. We will find out the cement content. So this is our cement content. So our cement content will be, you can say, minimum cementitious content will be 984. So we found the cement content, we find the water content, we have the aggregate content. So three values we got. So what we will do, we will find out the total volume, the weight divided by the specific weight of the each. We will find out the volume. This is the total volume fraction we have. We subtract it from the 27. This is the volume fraction of fine aggregate. So we multiply with the specific unit weight. We will find out the weight of fine aggregate. इस बात की समझ आई है बेटा जी कि नहीं? लास्ट स्टेप की समझ आई है आपको कि नहीं?
Yes, sir.
हम जैसे डिजाइन करते हैं ना यूनिट वॉल्यूम के लिए, तो हमने 3 वॉल्यूम निकाल ली हैं. सीमेंट का वॉल्यूम भी हमने फाइंड कर लिया है. वी हैव फाउंड आउट द वॉल्यूम ऑफ सीमेंट, coarse aggregate, we have found out the water volume, we have found out the air volume. So we subtract total volume we have calculated through these ingredients out of the 27, and then we multiply it with the specific weight. After multiplying it with the specific weight, we can find out the weight of fine aggregate. We have calculated all the weights: cement, fine aggregate, coarse aggregate, and water. This is the mixed design we got at the trial. You can say approximate mixed design. Are we clear until now or not?
Yes, sir, clear.
So we found out the 4 mixed proportions, approximate mixed proportions. So as you know, in the high strength mixed design, we use the cementitious materials. Cementitious materials can be fly ash, can be cement, can be silica fume, can be metakaolin, anything. So we do with the class C fly ash. It is stated that you apply 20 to 35%. So 4 companion compositions. So you need to replace it with the cement. 20% replacement of the cement. What is the weight of the cement? What is the weight of cement? Can anybody tell me?
984, sir.
984. उस 984 का 20 आप लेंगे, there is 197 and the rest will be cement. 787 plus 197 will be 984. Then 25% is 246 और बाकी का आपके पास सीमेंट आ जाएगा. 30% again 295 or 689. So accordingly your total weight of the cement will remain same, but you will replace it with 20% fly ash. You got it or not?
Yes, sir.
बात समझ आई है जी कि अगर आपके पास 100 ग्राम सीमेंट है तो आपने उसमें 20% रिप्लेसमेंट करनी है, तो क्या करेंगे आप? 20 फ्लाई ऐश आ जाएगा और 80 आपके पास सीमेंट आ जाएगा. 25% Hello students, can you hear me?
Yes.
Yes, sir.
Okay, sorry, I was disconnected. So we were talking about the percentage replacement of cement by fly ash. So I was saying that if 20% replacement means, let's say there is 100 grams of cement. So if we replace 20%, it means 20 grams of fly ash and 80 grams of cement. Is it clear?
Yes, sir.
Okay. Okay, so it means after finding out the exact proportion of the cement, that was 984, whatever you get in your case, then you go for the replacement values. उसके बाद आप replacement values पर जाएंगे. So if you should go, so your cement content, your trial batches will be accordingly adjusted. Your cement will be accordingly this percentage of cubic feet if you convert this procedure, this weight into volume. Then this ACI report, ACI 2 11.4 or 8. So this is also being scanned and put up in the slides as well for your reference if you want to read it. That's all for the mixed design. If you have any questions, students, you can ask.
सर।
बेटा अगर कोई क्वेश्चन है तो आप पूछ लें, क्योंकि नेक्स्ट वीक में इसमें से क्वेश्चन आएगा पेपर में, ये बात याद रखिएगा।
सर अगर इसमें से ये जैसे अभी आपने हमें ये सारी एग्जांपल समझाई है, अगर न्यूमेरिकल हमें आता है तो सर ये जो टेबल्स की वैल्यूज वगैरह हैं
ये टेबल गिवन होंगे,
ये गिवन हो गए सारी वैल्यूज वगैरह, लाइक हमने कोई फॉर्मूला शीट नहीं बनाने की जरूरत।
नहीं नहीं नहीं, आपने कोई फार्मूला शीट नहीं बनानी, ये टेबल गिवन होंगे, जो आपने यूज करने हैं वो गिवन होंगे टेबल।
ठीक है सर।
आपको कोई चीज याद करने की जरूरत नहीं है, these will be given to you, but you need to know the steps actually कि कौन कौन से steps पे चलना है। चलिए जी, आपने कुछ नहीं पूछा, मैं पूछता हूँ बेटा, ये नॉमिनल मैक्सिमम साइज ऑफ एग्रीगेट क्या होता है? Can anybody tell?
सर ये स्मॉलेस्ट सीप साइज वगैरह जो अलाउ उसको करते हैं एग्रीगेट को कि वो पास थ्रू कर जाए, और 5% तक ये तकरीबन मटेरियल रुक जाता है।
Anyone else कोई और इसको बताना चाहे? It is the smallest sieve size through which 95% of the material passes through. 5% रिटेन कर दो सीव, वो छोटे से छोटी सीव जिसमें से 95% मटेरियल गुजर जाए और 5% उस पर रह जाए, उसको कहते हैं जी आप नॉमिनल मैक्सिमम साइज। और मैक्सिमम साइज ऑफ एग्रीगेट उसको कहते हैं जिसमें से 100% मटेरियल पास कर जाए। सीआर कहाँ पे आपका सीआर है? यहाँ पे सीआर देयर, सीआर आर यू देयर? सीआर है जी यहाँ पे कि नहीं? एनीवन हु इज लिसनिंग प्लीज बताइएगा मुझे, आपके इस ग्रुप
सर
में
वो
सीआर?
एब्सेंट है आज। सर सीआर एब्सेंट है आज।
अच्छा, कोई और बंदा जो आप में से किन तमाम बच्चों की अटेंडेंस मार्क कर लें बेटा।